Hello everyone, let's solve some Leetcode today. Today we have Leetcode 78, that is subsets problem. In this problem we have been given a nums array that contains unique elements. It means we are not having any duplicate elements to skip. Now we have to return all the possible subsets from this particular array. What this simply means is that we have to return the power set of this array. The solution set must not contain any duplicate subset. Return the solution in any order. Here we have a simple array nums with 1, 2, 3 as elements to create a subset. As we can see here that we have a few subsets for this particular array. So what is a subset? A subset is nothing more than a collection of elements from the given array. For example, here we have the nums array as our input that contains 3 elements 1, 2 and 3, and here we have all the subset that we can generate from this particular array. So if we look at it here, we have a subset 1, 2. 1, 2 is actually nothing more than a simple collection of these particular 2 elements. In the same way we have 1, 3. So we have 1 and 3 as a collection in this particular subset. So that is what a subset is. You basically take a few elements from the array or take none of these elements from the array and create a new list, and that is simply a subset. And since we are taking elements from the array itself, the maximum length subset we can create is the array itself 1, 2, 3. So this particular array is a subset of itself also. Here are all the subsets for this particular array. Let us see how these are made. When we have 3 elements and we decide to choose none of them in our subset, we get an empty subset because it does not contain any element. Now when we only try to choose one and remove these 2 particular elements from the subset, then we have only a single element in the subset, so we create a subset with element 1. The same way for 2. If we only choose 2 and remove all the other elements, we get another subset that only contains 2. In the same way, if we decide to choose 1 and 2 to contain in our subset and remove the 3, we get this particular subset 1, 2. In the same way, if we decide to remove 1 and 2 and only contain 3, we get another subset that only contains the element 3. In the same way, if we decide to take 1 and 3 in our subset and we remove the 2, we get a subset with elements 1 and 3. In the same way, we can decide to remove 1 and only contain 2 and 3 in the subset, so we get another subset that contains 2 and 3. In a similar way, we can decide to take all the elements from our nums array and then it will create the nums array itself again as a subset. So as we can see that we are just basically choosing an element, removing other element, choosing another element, removing another element, choosing a group of elements and then removing the other group of elements to create any subset that we want. In the question we can see that we have been explicitly told that the solution must not contain the duplicate set. So what is a duplicate set? Well, if we think about it, if I try to take 1 and 2 only in our subset, then it's a subset, right? But what about if I try to take 2 and 1? Are these two different subsets? Well, no, they are the same subset because they contain the same elements. So these are equal subsets. So that is why we are saying that if we have 1, 2 in our answer here, then we must not contain 2, 1. And we can see that here also. In this particular output also, we have 1, 2 as our subset. So it means we cannot have 2, 1 as another subset because that will be a duplicate. So how do we know that how many subsets we can create from a particular given array? And this is where the permutation and combination works. At each of these elements, we have 2 choices. We can either take it or we can either skip this element and we don't take it. The same way we can do for 2. We can take it and we can skip it. In the same way we can do for 3. We can take it or we can skip it. If we take 1, we skip 2 and we take 3, we get a subset of 1, 3. In the same way, if we take 1, we skip 2 and then we also skip 3, then we get 1, 2. In this way, we can create all the possible subsets. So we have 2 choices at each given index. It means the number of choices or the number of outcomes from these choices will be 2 multiplied by 2 multiplied by 2 is equals to 2 raised to the power 3. And as we can see that we have 3 elements in our array 1, 2 and 3. It means the n or the length of this array is 3. So here we can say that the number of subsets will be equals to 2 raised to the power n, where n is the number of elements in the array. And so we have to figure out 2 raised to the power n subsets in our answer. Let us see how to create subset. Here we have an array with 1, 2 and 3 as elements. The index for these elements is 0, 1 and 2 respectively. Now at each index we know that we have a choice whether we can take that index or we can skip it. So that's exactly what we are going to do in our code also. So right now we are going to first of all create a decision tree. So the first index that I have is 0. I can either take this index or I can skip it. If I take it, then what will happen? I will have 1 here. If I skip it, my array will be nothing. It will be empty. Now let's move on to the next index, that is the index 1 or the element 2. I can decide to take this 2 or I can decide to not take this 2, and it will need to be decided on both these branches. So if I decide to take 2 on this branch, I will have 1 comma 2 as a subset. If I don't decide to take it, then I will again have just 1 in my array. Now here also I can decide to take 2. If I decide to take 2, I will have 2 in the array because it was an empty set. If I don't decide to take it, then I will again have an empty set here. In the same way, at each of these positions, I can decide whether I want to take 3 or I want to skip it. So if I decide to take 3 here, I will have 1, 2, 3 in my subset array, and if I do not take 3, I will only have 1 comma 2 in my subset array. In the same way, if I decide to take 3 here, I will have 1 comma 3. If I don't decide to take it here, I will again have only 1 as my subset. Here also, if I decide to take 3, I will have 2 comma 3. If I decide I don't want 3 here, then I will again have only 2 as my answer. Here also in the empty subset, I can decide to take 3, then I will put it here. And if I decide I don't want 3, then I will simply again have an empty subset. Now we have gone through all the elements in our nums array. If we try to go further, we will reach the index 3 that does not exist in our nums array. So we can definitely stop the execution now. So we have figured out all the subsets of this given array. All these leaf nodes are representing the subsets. Now understand that this structure that you can see here is not actually a tree. So all these things are actually not a node. These are simple choices or decisions that we made throughout the execution of code. And these decisions eventually led us to these particular outcomes, all these outcomes. So this decision tree is basically a way for us to understand how our choices will affect the given output. Here we are choosing between taking 1 or not taking 1. Here we are choosing between taking 2 or not taking 2. Here we are choosing between taking 3 or not taking 3. So this is basically a visual representation for us programmers to understand how our choices are going to affect the particular input and the output. Now of course we are going to use DFS and backtracking to solve this particular problem. We can see that we are going to need recursion to solve this particular problem. So let us see how the recursion flow will work. First our code will be on 0th index. Then we will decide whether we want to take it or we don't want to take it. So suppose we decide we want to take it in the first line, then we will go here. So the recursion will go to this particular place. Remember that we are not touching this right now. Now in our subset array we only have 1. Now we move on to the next element and we see 2. Now we have to decide here whether we want to take 2 or not. So in our code we decide to take 2 and we will reach at this particular position. So we have 1 and 2 in our subset till now. Now we move on to the next one, that is 2, and we decide whether we want to take 3 or not. Then here we decide to take 3 and we have this particular subset. Now we will have a result array in which we are going to store a copy of these subsets. So suppose that this subset is called S1 and I'm storing this S1 here. Now the index will shift again and we see that we are out of bounds. So we will not go anywhere after this particular step, and since it is a recursion, this particular call will end and we will go back to this particular state. We can choose not to take 3 and we go to this particular branch. Now we are reaching the S2 subset. We only have 1 comma 2 subset, and if we try to further go to the next index, we see that we are going to get out of bound index. So we are going to get 3 here. So we can stop and we store the S2 subset also in the result array. Now the function call will end here and we will go back from this position back to the 1 comma 2 again. And here this entire thing is done. So we will go back to this particular state. Now we only have 1 in our subset, and here we go to the other path. We decide that we don't want to take 2. We go to this particular place. We have 1, and when we backtrack we also change the index. So right now we are on index 1 here. Now at this particular position we again move to the next index 2 and we decide whether we want to take 3 or not. If we decide to take 3, we will have another subset S3. We will make a copy of this subset. We will store it here. Then we will go back because we will run out of indexes, and we will of course go back to the index number 2. And here we can decide that we don't want to take 3 elements, so we will go to this S4 set. We will now store this S4 set and then we will go back to this particular position. The index is again 1. Now since this particular place is done, we will go back to this particular one. The index is again shifted here, and now from this particular one we go back to this particular 0th index. Now here we can actually go to the next branch, that is we decide that we don't want to take 1, that we don't want to take this first element. So we will go here. We have an empty element now because we did not take anything. Now the index is 1. We are at this particular position. Now we can decide whether we want to take 1 or not. So in the code we are always taking the particular index in the first choice and then we are coming back and neglecting it. So first in the code we will take it. So we are taking the 2 and then the index will shift again. So now we are deciding between 3. We will take or not take 3. So first we will take the 3 and then we will get the S5. Then we will make a copy of S5. We will store it in the result array. Then we will go back. Then the index will also shift again. So index is not this anymore. So the index is now 1 again. Now we will take the another possibility, that is not taking 3. We will reach this particular subset as 6. We will make a copy of it. We will store it. Then we will go back to this particular one. The index will again change to first index. Right now this particular page is done, so we will go back to this particular index. So now we are back here. Now we go to the next possibility of not taking this particular element. So we again have an empty array. We did not take it. Now we can decide between this one. Now we decide to take it, then we get this S7, store here S7, then we come back and then we go to the next possibility, that is not taking it. So we again have this S8, that is empty set. Then we go back here. Since it is done, we go back here again. Then we again go back here, and now it is completely done. So this is basically how our result will be formed, and this is the result that we need to send back as answer. Now let's go through the code. First of all, I have defined the result array here in which all the subsets will be stored. Then this is the function that will actually generate all the subsets. In this function, first of all, we are taking the index at which we are starting. Then we are taking a subset array in which the intermediate subsets will be stored. Since it is a recursion function, we have a base condition here. We are saying that whenever this source index will become greater than or equal to the length of this particular nums array, we know that we have gone out of bounds for this particular nums. So we have reached a particular subset. At that point, we are saying that okay, make a copy of this particular subset and store that into the result array and simply return, because there is nothing else to do after this index. If this condition is not true, it means that we are still in the middle process of creating the subset, and so we will go on. Here we are making a choice of taking it first and going in that direction. I will append the current element into the subset array, and then I will send this subset array into the next DFS call or the next recursive call for the next index. Now here I am deciding that okay, I don't want the current element. So yes, here I actually added the current element, right? So I will again have to remove this particular current element. So I will simply pop and then I will send the subset. So right now this particular subset does not contain the current element, so it does not have it. And of course I'm passing the next index that I would like to make this choice on for both of these DFS calls. Now this entire function runs in the same way we discussed here, how the code will flow. And here I'm calling the function with start index as 0 and an empty subset array. We are going to add and remove the elements in this subset array within our code, and at the end we will simply make a copy of it and then append it in the rest. And here I'm simply returning the answer. One thing to notice is that I'm creating a copy of this subset array here. The reason is that when this particular DFS call will end and we will go back to a previous call, this subset array will change. Here we are actually popping the elements from this particular subset array, and the value in these functions are passed by reference, not by value. So it means that if I just say okay, append subset, not a copy, then this subset will change inside of our res array itself, and that is not what we want. We want to make a separate copy that will not change in our result array. So that is why we are making a copy and storing it in the result array. Now let's run it and see what happens. So it works, beats 100% in 0 milliseconds. Don't trust Leetcode compiler. Now let us talk about the space and time complexities. We know that we are going to have to deal with 2 raised to the power n subsets, so anyways we will have to make 2 raised to the power n calls. It means that time complexity will anyways become 2 raised to the power n. The tricky part is space complexity. Usually people say that it is order of n, and they are somewhat right also, because they are talking about auxiliary space. Auxiliary space is basically a space used by recursion call stack. So yes, in case you are talking about recursion and its call stack, the space complexity is order of n. But if you are talking about the output array, the output array is basically a list of lists, and that is not order of n. So when we talk about output, we know that the output will contain 2 raised to the power n lists themselves, and each list will have an average size of n by 2. N is the number of elements in the given array. Why is the average size of list n by 2? It is because some lists will have 1 element, some lists will have 2 elements, some lists will have 3 elements, some lists will have 4 elements. Then at the end, there will be a list that will contain all elements. So when you take the average of sums of all these lists, you will get n by 2. So what we are saying is that we are going to store these many lists, and each list will have a size of n. So it means that I have a list of n by 2. I am storing it this number of times. So it will become 2 raised to the power n. So basically the space complexity will become n by 2 into 2 raised to the power n. And since we do not actually consider the constant stuff, we can say that order of 1 by 2 into n into 2 raised to the power n is simply equals to order of n into 2 raised to the power n. This is basically the total space complexity for the given output. So if you like the solution, please like, share and subscribe the channel. And if you have some topic or question that you would like me to target, just let me know in the comments. Now we will meet in the next video. Till then, bye.